Hey guys, this is the last video in this unit called Miscellaneous Topics. It actually comes from section 2.7, not that that means anything to you because you don't have a textbook. But we're going to solve polynomial and rational inequalities. I kind of like these. Of course, you know how I feel about quadratics. I think we should all be good at solving quadratics. I think we should all be good at factoring. I love to factor, so I kind of like these. So here we go. We have a quadratic inequality. And so your first thought in dealing with quadratics should always be to get it set equal to 0. So the first thing I did was I got it set equal to 0. I recognized that it was factorable. And this should just kind of be instinctual by now. Set equal to 0, factor 4, negative 3. Bam. Like those, that should kind of happen on instinct for you. So the numbers that I want you to get out of this are positive 4 and negative 3. Now, we are going to take these numbers, we're going to put them on a number line, but we're going to use open circles. Do you see why we're going to use open circles? We're going to put an open circle on 4 and an open circle on negative 3 on our number line. Open circle, open circle. Next, we need to know what we're going to take our pencil and fill in. Am I going to fill, so I basically divided a huge number line into 3 sections. I've got this ginormous section that goes to negative infinity. I've got this smallish section between this circle and this circle, and I've got this ginormous section that goes all the way to infinity. I need to know which of those sections to color on my coloring project. So what I'm going to do, I'm first going to show you the way to use your brain to figure out which section to color. If I'm over your head, stick with me because I'll show you a way to use your calculator to figure out which way to color, okay? So I want you to check all 3 sections, and I've color-coded them. I've color-coded this one that goes to negative infinity with green, this one with pink, and this one with blue. So to use your brain, I would like you to look at the factored version of your quadratic. So I want you to look at this. Ready? I want you to pick a number in the green region. Sometimes I like to pick an absurdly negative number, not just negative 5, just like, be creative. Negative 10. How about negative 100? Pick negative 100. Ready? If I sub in negative 100 here and here, negative 100 minus 4, I don't need to know what it is. I just need to know whether it's positive or negative. So negative 100 minus 4 is negative. I'm going to write that down. Or you don't have to write it down, but you can remember. Negative 100 minus plus 3 is negative. So what I end up getting, plugging in a green negative 100, this set of parentheses is negative, and this set of parentheses is negative. And what do you get when you take a negative times a negative? Do you get something that is greater than 0? Well, yeah, you do. So the green section works. I am going to color in the green section. Let's check the pink section. If 0 is in my pink section, I always like to use 0. And again, I like to go to the factored version. I don't need to know the value by plugging in 0. I just need to know whether it's positive or negative. So plug in 0, that's a negative. Plug in 0, that's a positive. Is a negative times a positive greater than 0? No. Pink section doesn't work, don't color it. Blue section. You've got well, you've got decimals in here. Let's not use those. You've got from 5 to infinity. How about something absurdly big like 100? 100 is in our blue section. Ready? Plug in 100. 100 minus 4 is positive. 100 plus 3 is positive. Is a positive times a positive greater than 0? Why, yes, it is. The blue section works. color the blue section. Therefore, my solution set is from negative infinity to negative 3. Don't include the negative 3. And the blue section. From 4 to positive infinity, don't include the 4. Okay? Now, I said I would show you the way to not use your brain, but use a calculator instead. So here's what I'm hoping. I'm hoping that most of you can do this way. Figure out which regions to color by picking a number, subbing it in the factored version to see either yes, no, or yes. Some of you's brains just aren't that good at math. So, if you would rather not do this and use your brain, if you would rather strictly rely on your calculator, here's what you can do. You can actually pick a number in the green region and you can sub it into your original, well, you can sub it in anywhere, but if you sub it in here, you have a lot more typing to do, right? If you sub it in the original, there's not as much typing in your calculator. So you can sub it in the original, and here's what that would look like. Pick a green number, sub it in the original. So negative 5 squared minus negative 5, is that greater than 12? So do this on your calculator and see if you get a result that's bigger than 12. You will. It works. Pick a legit number in the pink section. Sub it in your original. Type it in on your calculator. See if you get an answer that's bigger than 12. You don't. Pick a number in the blue section. Sub it in your original. See if you get a number bigger than 12. You will. Okay? However, if you refuse to use your brain and strictly go with the calculator version, don't even think about signing up for calculus. I know that's a long way away, but we are very brain oriented in calculus, not calculator oriented. So if this is not good for you, if you can't use your brain in this way, keep in mind we do a lot of this in calculus, not necessarily a lot of that. Okay. Moving on. Next one. Oh, it's already been factored for us. Woohoo! Already set equals 0. It's already factored. So the number that jumps into my head is x could be 4, negative 1. These are the two numbers that you need to go put on your number line and color them in. So I colored in 1 and I colored in 4. I've divided my graph into 3 regions. I've got this green region, this very small pink region, and this blue region. So I'm going to go over the brain method with you. We're going to use our brains. Ready? Pick a number in the green region, like negative 100. If I pick negative 100, this turns it to positive 100. So 100 plus 4, that's positive. Negative 100 minus, that's negative. Is a positive times a negative greater than or equal to 0? No. Do not color it. Pick a number in the pink region. I don't care. 2. Pick a number in the pink region. Negative 2 plus 4 is positive. Negative 2 minus, no, sorry, I chose positive 2. My bad. Positive. Okay, so negative 2 plus 4 is positive. I picked a positive. Positive 2 minus 1 is positive. A positive times a positive, yes. We're going to color in the pink region. Color this in. And then pick a number from the blue region, like 100. This turns it negative. Negative 100 plus 4 is negative. Positive 100 minus 1 is positive. Is a negative times a positive greater than or equal? No. So our solution set goes from 1 to 4. They are colored in, so you need to include them. Next one, it's cubic. Your first thought should be, hey, I think I'll set it equal to 0. So set it equal to 0. At some point you might be thinking, dang, I'm not real good at cubics. That's okay, because they have a common factor of x squared. Pull it out. Here's what's left. Here are the numbers you need to have in your mind, 0 and 6. Put them on your graph and color them in. Put them on your graph, color them in. Zero and 6. So we got to check from the green region over here. You can do like, let's see, from the green region, you can do like negative 100. So negative 100 squared is positive times negative 100 minus 6 is negative. Positive, nope. Pick a number from the pink region, the middle, like 2. Positive 2. 2 squared. 2 minus 6. No, don't color the pink region. Pick a number from the blue region. Like, I don't know, 100. 100 squared. 100 minus 6. Yes, color the blue region. So our solution set starts at 6. It's colored, so include it, and go to infinity. Next one, a cubic. It's already set equal to 0. And your first thought may be, oh gosh, I'm not that good at cubics. That's okay, I'm not either. So the first thing I'm going to look for is, please let there be a common factor. There's not. They don't all have an x in them. So the next thing I'm going to try to do is, can we factor by grouping? So if I group these two, can I pull out a common factor? And can I group these two and pull out a common factor? And you can. From here you can pull out an x squared, and from here you can pull out a 49. X squared, this is what's left. 49, this is what's left. Now, in order for factoring by grouping to work, this has to be your result. If you're going to factor by grouping, the leftovers that you get after you pull out this one and the leftovers that you get after you pull out this one have to be the same. And then you can say, okay, I'm going to put this x squared with this. What you're actually doing is you're saying, look, this whole thing and this whole thing have a common factor of x plus 1, and you're pulling out an x plus 1. And when you pull out an x plus 1, this is what's left from here, and this is what's left from here. Okay, so we have factored by grouping, and it turns out that, so negative 1 pops into your head right here because negative 1 plus 1 is 0. There's nothing you can plug in for x and square it and add positive 49 to get 0. So from this right here, there's not a solution that comes from there. So the only number we have to put on our number line is negative 1. And we're going to use an open circle. Negative 1. Put it on, open circle. Now I only have 2 regions to check. The left side of negative 1 and the right side of negative 1. So let's check the left side. Let's check the green region. Ready? And again, I like to choose kind of absurd negative numbers. So if I choose negative 100 squared plus 49 gets me a positive. Negative 100 plus 1 gets me a negative. Is that true? It is. So I want to color the green region. Okay, now don't stop. Go ahead and check the other one. The green one definitely gets colored. So let's check the pink. And the pink goes all the way to infinity, so I could check an absurdly large number like 100. 100 squared plus 49, that's positive. 100 plus 1, that's positive. Is this true? No, it's not. So we've only colored the green region, and my solution set is from negative infinity to negative 1. Oh, wait, hold on. Hold on. I caught it. I'm a little slower than most of you. Most of you have probably caught it by now. I totally should have made that an open circle. I said make it an open circle, but I didn't. All right. There you go. Okay, one more. Number 5. This is a rational expression. It's a polynomial over a polynomial. And we've got to figure out what x values cause this to be greater than or equal to 1. The first thing I want you to think about, if I'm going to color all of my possibilities, is there any number that you can automatically say, stop, Miss Neal, don't color that number? Is there any number you can think of that you don't want me to include in my coloring? Is there any number you can think of that you don't want me to include in my domain? If you've thought of the number that you don't want me to include, thank you. You just saved me from blowing up. So most of you recognize this rational expression is going to blow up when x is negative 1. Let's not use that number. So the way to say, let's not use negative 1 is go to your graph and make sure you just put an open circle on there right before we start. Don't what am I trying to say? Yeah, just do not let us use that number. That will never be colored in. You'll blow up the moment you color that in. Alrighty. So that's to get started. And then to figure out how to solve it. The first thing I would do is make sure that I have a fraction on both sides. So this was a fraction. I turned my right side into a fraction. And if you want to carry your symbol straight down without flipping it or anything, cross multiply and write them this way. So cross multiply here and write it on the left side. Cross multiply like this and write it on the right side. And if you do it that way, your symbol can come straight down. Okay? And then I subtracted x from each side, and I got x is greater than or equal to 1. X is greater than or equal to 1. So I went ahead and colored it in. X is greater than or equal to 1. Real quick check though. Remember, we divided our graph up originally. We put an open circle here. So we know this region works. We were told for sure the black region works. Check the pink, check the green, just to be sure. So I picked an actual number from the pink. I picked 0 and I subbed it in the original. So 2 times 0, 0 plus 1, is that greater than or equal to 1? No, it's not. Don't color that tiny little pink region. And then I picked a number from the blue region, and apparently I picked I don't know what I picked. -4? Did I pick -4? I don't know what I did. Let me pick it again. So what if I choose -4? 2 times -4 is -8. -4 plus 1. -4 plus 1 is -3. -3. And turns out -8 divided by -3 is positive 2 point something. So the green region does work. Okay. Color this in. Careful, don't color in the open circle. You're going to blow up. All right, so now write your solution set. So we're going to go from -infinity. Stop at -1. Don't include it. Be careful. Don't blow yourself up. And from +1, include it to infinity. And remember, my math lab's going to want the U in there, but I don't care. Right? Okay, have fun using your brain. Brains, no calculators.